Welcome to Lab 4 on the Spring Mass System. In this lab, I observed the motion of an object oscillating vertically and horizontally on the edge of a spring. I made use of the energy principle, the formula for the force of gravity, as well as the formula for the spring force. As we learned, the energy principle states that the total change in energy in a system will be equal to its change in kinetic energy plus its change in this case, potential spring energy plus its potential change in gravitational energy. Since these were the only forces involved, these were the only forces I included. The force of gravity is equal to the vector 0, negative mass times the constant g, 0. The spring force is equal to the negative spring constant times S times L hat, and the net force is equal to the sum of the two forces. Here is my tracker video. As you can see, there are two graphs. This one, is depicting the mass's oscillation about the x-axis, and this graph depicts the mass's oscillation about the y-axis. Here is my Python code. When I first opened the starter program, I first inputted the objects at the edge of the spring's mass, because this is the only thing I knew. After analyzing the tracker video, I then inputted the initial position and its initial velocity. Next, I inputted the necessary constants such as g, the spring constant, L0, L hat, and S. In these lines of code, I told Python how to calculate kinetic energy, potential gravitational energy, and potential spring energy. Here, I simply took the formulas in the PowerPoint and turned them into Python code. These two lines, I simply told Python how to calculate the mass's new velocity and position. Finally, here, Python calculated the changed kinetic energy, the change in potential gravitational energy, the change in potential spring energy, and delta E total, which was simply the sum of all the changes. Here is my module. The yellow line represents delta E total, and as you can see, it is squarely on 0, the x-axis. This means that the sum of all these energies is 0. Here in the actual model, this blue ball represents the Python predictions, and the red ball represents the tracker predictions. As you can see, there is a large discrepancy between the two. There could be several reasons for this. In tracker, I may have miscalculated the center of mass in each frame. This would have definitely contributed to this discrepancy. Also, I may have misplaced the origin, which would have also contributed. What does it mean? For my model system, was the energy principles truly satisfied? Yes. As I had showed, delta E, the total sum of the change in energies represented by the yellow line, was, as we had expected, 0, as there were no interactions between the system and its surroundings. And for the graphs in tracker, were the periods of oscillation for graph about the x-axis and for the y-axis? No. In my graph TY, representing the mass's oscillation about the y-axis, evidently oscillated at a faster rate as its graph contains 6 oscillations, while the graph depicting the mass's oscillation about the x-axis had only 5.5 oscillations. This is because the mass on the spring fell and rose at a faster pace than the speed with which it moved left and right. Thank you for watching my lab report, and I hope you enjoyed it.